Your online application's starting to fail. It's crawling on the network just as fast as a snail. We need evented programming starting from the top. Better write some code so the world doesn't stop. With the non-blocking model, we will be just fine. Built on Google Chrome's V8 runtime. And all you need to do is write some JavaScript code and use the real-time web with Node.
You're watching Real-Time Web with Node.js. In Level 7, we're going to be continuing to build our chat application, and we're going to introduce some persistence. One of the limitations of the chat application that we wrote in Level 6 was that when a client connected, we didn't show them the recent messages that were sent in that chat room. As you can see here, when Spider connects, he doesn't see any of the messages that Dog has sent previously. So let's walk through how we would add that functionality to our app. So currently on the server, our code looks like this. But we need to add some code that will emit the recent messages when our new client connects. So our first iteration of this, let's just use an in-memory array to store recent messages. So first, let's just create an empty array. We're defining a store message function that takes the name and the data of the message, and we're going to push that onto the messages array. If that messages array is longer than 10 elements, we're going to remove the oldest element by calling shift. Down in the messages event handler, we're going to call this store message function to insert our message into the array. Now when our client joins the chat, we're going to use the for each function to iterate over the messages array and emit a new message for each item in that array. Let's go back and see what that does. Now when Dog is connected and he sends out a couple messages, when Spider connects later on and enters his name, he'll receive those previously sent messages by Dog. And there's a little bit of a problem with this. What happens if we restart our Node application and then a new client connects? Are they going to see those previously sent messages? Well, they're not, because we were storing those messages in a in-memory array. Whenever we restarted that application, those messages were lost. To solve this problem, we need a way to persist these messages outside of our Node process. Let's say like a file system or a data store. And luckily, Node works really great with a bunch of data stores, like MongoDB, CouchDB, PostgreSQL, Memcached, React, and Redis, which is a key value store. You can use all of these persisting data stores in Node.js in a non-blocking way. And what's great about that is, say you can send a query and you can tell it to call back when the results come in, instead of having to block and wait for those results. So for our chat application, we're actually going to choose to use the Redis library to do persisting messages. Redis is a key value store, but more importantly, it doesn't just store strings as value. It can store things like lists, hashes, sets, sorted sets, and you interact with all of these data structures in Redis using these commands. Redis has a really great documentation website where you can go and search for commands by the data structure. And let's say we wanted to learn how to use the get command. So all we do is get, and then we pass in a certain key. But what's really great about this website is that you can actually run these Redis commands right on the website, just like Code School. So I can do set new key equals to Dog, and then when I run get new key, I get the value Dog back. Let's say I wanted to learn about how to use lists. I can go to the lpush command, which means just push a new value onto a list. I'm going to go in here and experiment with this command. I can run lpush new list. I can push Dog onto that list, and then I can push cat, and I can see that my list is getting bigger, and then I can use the lrange command to get those values back. Pretty cool. There is a really great third-party library called Node.js for working with the Redis library, and it's completely non-blocking, like I said before. Let's see how we would use the Redis module. First, we just run npm install Redis. Then in our application, we can require the Redis module and then create a new client using create client. Finally, we use the set command to set hello, yes, this is dog to the key message 1, and we're doing the same thing pretty much for setting the key for message 2. Then when we want to get back out that information, we run client get. We pass in the name of the key and a callback that will be called when the result is ready. For our chat application, we're probably going to want to use something like lists, right? We had an array before, so now we're going to want to translate that into using Redis lists. But first, let's look how would you use lists in Redis. Here I'm pushing a new message onto the messages list, and the callback that gets called will reply with the length of that list if I want that. I can go ahead and do that again, and now I have 2 items in my list. And a really common pattern in Redis is to combine the use of lpush, where we add a new item to a list, and when the callback is called, we call ltrim, which in this case will remove all but the first 2 items in the list. This allows you to cap the length of your list. When we want to retrieve all the items from that list, we use the lrange command, and we pass in the key, the starting index, and the end index. In this example, we're using -1, which just means give me all of the messages in the list. Now that we've explored the Redis API a little bit, let's go ahead and convert our chat application to using Node Redis. And let's start with the store message function from before. We're going to update this function to use Redis lists. So as you saw before, we were just pushing new messages onto the array, but now we're going to need to use the Redis client. So let's first create that client. In our store message function, we have to use JSON to stringify our message object so we can store that in the list. Then we'll use the lpush command again and push that message onto the messages list. And when we get a response from that, we're going to use the ltrim command to make sure that we only have the newest 10 items in the list. Now all we have to do is update the code that outputs these messages. We're going to want to reverse those messages so they come out in the right order. Then we can loop through each message like before, but this time before we emit the message, we have to use JSON parse to get back out the JSON object. Let's see how that fixes our chat app now that we're using persisting stores. So our dog connects and sends a couple messages. And now when our spider connects, he gets those messages. He can send a couple himself. We're going to go back and restart our Node application. And now when we connect with a third client, we can see that our messages show up just like they should. Now let's add a new bit of functionality and implement that chatter list that we saw on the left side. This is just going to show who is currently connected to the chat room. And for this, instead of lists, we're actually going to use a different data structure, Redis sets. And a set is pretty similar to a list, but instead of just having everything in there, it can only be unique data. So for a list of names, this will work because the names need to be unique. We can add to the set by using the sadd command, and here we're adding 3 members to the names set. We can remove values from the set using the srem command. When we want to retrieve all the members of a set, we use the smembers command, and that will call the callback with an array of names of everyone in the set. So let's jump right into using sets to implement this feature. When a client joins, we're going to do 2 new things. First, we want to notify all the other clients that a new chatter has just joined the chat. We also want to use the Redis client library to add the person's name to the chatter set. Then we'll go back to our client, and we're going to add a new listener on that add chatter event that we added in the server. And when that event gets emitted, we're going to call the insert chatter function defined here. The insert chatter function just creates a new list item with the name, and it appends it to the chatters unordered list in the DOM. We actually want to do one more thing when the client joins the server. We can use the smembers command to get back all the names that are currently in the chat room, and then we can loop through those names and emit those names on the add chatter event. Conversely, when a chatter leaves the room, we want to remove them from that list. So in our application, we're going to listen to a new event on our client called disconnect. And when that client disconnects, we're going to first grab their name off the socket, broadcast out to all the other clients that this chatter has left, and then remove them from the chatter set. On our client, we're going to listen to the remove chatter event, and when that's fired, we're going to find the LI in the list and remove it from the DOM. Let's see that in action. So our first client is connected, dog. We can see he's already in the room. So he's going to send a message. And now when Spider connects, he's going to see that dog is already connected, and he's going to see that message from before. We go back to the dog client, we can see that now he knows that Spider is in the room. When a third client connects, he'll also see everyone who's currently in the room, and the other two clients will also see that he's joined. So dog has to go for a walk, and now when he leaves the room, the other two clients are going to see that he's left. Well, now we've reached the end of the course. Actually, it's the end for me. You still have a little bit more work to do in the challenges. And when you finish up the challenges, you'll earn our last badge, and we'll see you on the wrap-up video.